Okay, gang, we're going to find the tangent and the normal line of this point on this graph. Just a reminder, the tangent line touches the graph at one point, whatever this looks like, and the normal line will be perpendicular to what the tangent line is. So the normal is perpendicular to the tangent. Okay, so let's start with the derivative. So first times the derivative of the second plus the second times the derivative of the first plus the derivative of this is 2y. The derivative of 2 is 2y. Derivative then the y is dy dx. And the derivative of 0 is 0. Just going to swap the order of that. Alright, I just moved it down so we could just see it a little better. Alright, gang, just a reminder, you do not want to have a fraction in here before you isolate dy dx, because it will create a complex fraction shortly, which you can't leave that as a form. So I'm going to now multiply everybody by x to get rid of this fraction. So I'm multiplying everybody by the LCD. Not an equal sign, a plus. Okay, so I got rid of the fraction. We don't want to think of this as a fraction. This is just like we want to think of this as a fancy symbol for y prime. So that's why I'm not fiddling with that. I just want to get rid of this 1 over x. Got to get that out of the bottom. Okay, so now I'm going to isolate dy dx. So I want to first get all the terms with the dy dx on one side. So this is dy dx and so does this. So this one doesn't, so I'm going to move this over to the right. Okay, now that I've got the terms with dy dx in it, now I can go ahead and isolate the dy dx. It's now a common factor of the two terms on the left. So I'm going to take it out as a common factor. All right, now I'm going to divide this off so I can isolate it. Okay, so that is the generic derivative. We are going to find what the specific slope is at this coordinate, okay? All right, let me just rewrite the point over here. Just give me a second to get my marbles in a row. Okay, that's my point. All right, so I now, because what I'm going to do is I'm going to create the tangent line. And to do that, I need m and b. So right now I'm going for the m by using the derivative. All right, so dy dx negative y. So it's negative 1 x ln x. So e ln e plus 2xy. 2x is e, y is negative 1. Okay. All right, negative, make a positive. ln of e is 1, so you have e times 1 here, which is e, plus 2 times this is negative 2e. Oh, interesting. Okay. So you want to think of this, you want to combine this. You want to think of this as 1e minus 2e's, or like 1 strawberry minus 2 strawberries, which will give you minus 1 strawberry, which you want to write as negative 1 over e. Alright, so that is the slope. So for the tangent line right now, we just got the slope. So we have the 1 over e to the x. So now we have to find the b. And if you recall, to find the b, you have to then plug in y, m, and x. So I'm going to go back and plug in those values. So y again is, oh, we don't need parentheses for that. Oh, I can't erase it. All right, so y is negative 1. 1 over e. X is e plus b. All right, so negative e and e cancel, so you have negative 1 plus b. That's going to give you a 0 when you add the 1 to the other side. All right, so y is equal to negative 1 over e to the x. All right, so when we fill in the equation, we know that m is negative 1 over e. We solved that b is 0, so that's going to go away. So this is the tangent line. And again, it's how you want to format it. You can multiply the e up to this side and move the x over. I mean, some people write this in all different ways. That would be x plus ey equals to negative 1. Hold on. It wouldn't be negative 1. It would be 0. Alright, we multiplied this up. We brought this over. It would be 0. Yep. Okay, so another way to write it is x plus ey equals to 0, or write it like this. Alright, that's the tangent line. Now we need to do the normal line. I know this is like 50 pages later. Alright, so like the normal line now, that's going to be perpendicular to the tangent line. So let's first look again at the tangent line slope. That was negative 1 over e, right? So this was the tangent line slope. So let's now find the slope of the normal line. So remember, this is perpendicular. So to find a perpendicular line, you have to do two things to the slope. You have to first reciprocate it or flip it. And you also have to make it opposite sign. So since this is negative, mine's positive. So again, you have to do two things to make a line perpendicular. You have to flip the slope, so reciprocate it, and make the sign opposite. All right, now we're back to creating the line now. Now I'm creating the normal line. So I have the slope, which we've decided is e, but just like with the tangent line, I have to now find b. And to find b, I'm going to do that, what I've been doing. I'm going to plug in that point. All right, so the y value, because you want the normal line at this point. So the y is negative 1. E times e plus b. So negative 1 equals to e squared plus b, or b equals to minus e squared minus 1. Okay. Alright, so y is going to equal to, the slope again is, these problems are so long I can't hold all the, okay, we said the slope was e, so e to the x minus e squared minus 1. Some people might just factor out the negative. Again, it's just how you want to format it. This sort of looks nicer, but it does, you know. Apples and oranges, you know what I'm saying? It's a fruit no matter what. So this is fine, okay? Alright gang, that's it on this one. Catch you. Bye-bye.